And you're always giving that little signal that, hey, we're recording. So don't pick your nose in front of everybody. All right. So normally when I start a Zoom session, I like to start with, do you have any questions? So do you have any questions?
Not yet.
Okay. That being the case, what I'm going to do is I'm going to take off this afternoon from where I left off yesterday afternoon. So normally on a Monday, Wednesday, and Thursday, we do problems from the back of the book. So I can show you, these are the things I expect to see on the test, this kind of work. So you get practice doing that. And you also get practice seeing how I think about things.
Perfect.
If you ever have any questions during that demonstration or during my example, you need to just pause me and say, hey, Tony, can you wait a moment and ask? What else was I going to tell you? And then I post these in the module 1 Q&A so that you can see the morning, the afternoon, or the evening, or all three. And of course, I don't expect you to watch all three, but we don't necessarily cover the same materials in all three.
Okay.
So let's go ahead and start. And I'm going to do a share where I share my desktop.
Perfect.
So this is my desktop. And here are some of the problems we've already covered in previous sessions. And where we had left off last time was problem 24, I believe. We had done number 22, which was how do you get an average? How do you calculate percent error? And so forth and so on. So if you want to see this, just open up a Zoom session from yesterday and look at the end.
Okay.
And we're going to start with 24. And we're going to express the following numbers in fixed notation. Fixed notation simply means don't use 10 to some power. So I'm going to show you how to do A and B, then I'm going to let you do B and C. So for A, we have 1.623 times 10 to the 3. So the 10 to the 3, this being a positive 3, means the fixed number is greater than 1. And the 3 also means move the decimal 3 places. So I'm going to take this decimal here, and if I move it 3 places this way, 1, 2, 3, and leave it right there, we would put zeros here and here, and we would get 0.001623. And if I move the decimal in the opposite direction and leave it there, I get 1623. So which of these is correct? And the answer is, well, that plus 3 means that the fixed number should be greater than 1. And the second one is greater than 1. The first one is less than 1. So you don't need to do this each time you're trying to figure out the answer. You just say, hey, if I move the decimal to the left, I'll get a number smaller than 1, and that's not cool. So I'll move it to the right. So the answer is 1623. And there's no real work to show with this problem. You either get it right or you get it wrong. So there's your answer. Now let's take a look at letter B. 2.57 times 10 to the minus 4. So the minus 4 means the fixed number is less than 1. And the 4 part means move the decimal 4 places. So you can probably see that if I move the decimal to the right, I'm going to have a number bigger than 1. So I'm going to move the decimal to the left 4 places. 1, 2, 3, 4. And that means 0.00257. And there's your answer. And the thing also I want to point out to you, let's see, your last name is Wynn. What's your first name?
Jessica.
Jessica. Okay, Jessica. So the other thing I want to point out to you is that the number of significant figures in the fixed notation is the same as the number of significant figures in the scientific notation. This has 3, the 2, 5, and 7. This has 3 because leading zeros don't count.
Okay.
They never count, ever, ever, ever. And in fact, when I write a number out like this one here, I like to write it this way. I like to put the 0 in front of the decimal because it helps you to not overlook the decimal, but it's not required.
Okay.
Okay, that being said, I want you to convert C and D into fixed notation. And you see this fourth number here?
Uh-huh.
This is 3404.
Okay.
And what I ask students to do is when they're done, they just tell me they're done. I don't ask you for the answer. I will show you my answer so I don't put you on the spot. You're just telling me you're done.
Okay, perfect.
And I should interrupt you really quickly. That also means that if you can't figure it out, you say you're done.
I'm done.
No, you can't figure it out, you're done. Okay, so let's take a look at C. 6.32 times 10 to the minus 2. So the negative means I need to make this number smaller. So I'm going to move the decimal over 2 places. 1, 2. You're going to put a 0 there and the decimal there, so you get 0.0632. And that represents the same as this number here.
Okay.
And for D, because that's a 3, and by default a positive 3, I need to make this bigger, so I'm going to move the decimal over 3 places. And I'm going to get 3404. Now, I'm going to show you something that I didn't show other folks, but it just occurred to me that maybe it might be helpful. So this is the calculator I like to use because it's inexpensive, solar powered, and it has everything you need for this class. So right now, if I zoom in on this, let me find my remote control. Here it is. So that's a little too zoomed in. But at any rate, can you see at the bottom here that says psi? That means scientific notation on this calculator.
Okay.
And I can switch between scientific notation and fixed notation by hitting this second science engineering. So anything in blue on the above, to get to that menu, I need to push the second button. So flow is the fixed notation and science is the scientific notation. So I can actually go back and forth. I'm going to leave this on scientific notation for right now, and I just press equal. So I'm going to write 1.623 times 10 to the third. So this is A. And to do 10 to the third, there's 2 ways to do it. There's the best way, and then there's the other way. The best way is to use this little button here that says EE. So what I'm going to do, I'm going to press second, EE, and I'm going to push 3. Now the way this calculator thinks about this number is it thinks 1.623 times 10 to the 3. So the letter E means times 10 to the. So 3 is the power that you're raising 10 to. Now watch what happens when I push equal. Do you see how it says 1.623 times 10 to the third power?
Yeah.
Now, watch what happens when I hit second science engineering, and I'm going to use my scroll button to scroll to flow, and I'm going to put equal or enter, and it changed the number to fixed decimal.
Okay.
So your calculator can actually do these things for you, and you can check them.
Perfect.
Whatever calculator you have, you can do the same thing. It might not be the same steps,
Okay.
but I suggest buying one of these because you can get them at Walmart for about 10 to 15 bucks, Target for 10 to $15.
Okay.
And I like it better than those $100 TI-83s. But if you have a TI-83, you can use that one too.
Okay.
Okay, so let's go ahead and move on. So the next problem we're going to look at is number 26. And here we're going to practice the following operations. And I need to zoom out so you can see what we're looking at. So carry out the following operations, provide the answer with the correct number of significant figures. So what we're practicing here are the rules for significant figures. And you need to memorize these three major rules is for multiplication, division. The answer has the same number of zig figs as the beginning answer or the beginning number with the fewest. And I do a lot of abbreviation in my notes. So that means number in this particular case because nothing else makes sense. Same hashtag, that doesn't make sense. Same pound, that doesn't make sense. Same tic-tac-toe, that doesn't make sense. So that also represents number. Same number, SF, not San Francisco, but significant figures. And then with the least. The addition, subtraction, the answer has the same precision as the beginning number with the least. So you can see the rules are similar, except for one is about the number of significant figures and one is about the precision. So when we look at precision, if we add 2.3 to 2, we get 4.3. This is precise to the 10th. This is precise to the ones. So ones is less precise than 10th. So we round to the ones. So our answer becomes 4. And if we had 5.5 and 5.5, this is precise to the 10th. This is precise to the 10th. So our answer is precise to the 10th. We add this together, we get a 0 here, carry the 1, and we get 11. So our answer is 11.0, which actually has 3 significant figures, whereas 5.5 only has 2. So when you add numbers together, you could get more zig figs in your answer than in your beginning numbers. You could also get fewer. Okay, and then 3 is when you round. So here, once you decide where you're going to round, once you decide where, and that means do you round to the ones, to the 10th, to the 100th, wherever you round to, you look at the number to the right. And that number to the right, if it's 5 or greater, you round up. And if it's 4 or less, you round down. So you want to know those rules and apply them as we're using them over here in the next problem. Okay, so in the next problem, you can see that we don't have any addition or subtraction. We're only going to use multiplication rules here. And for the multiplication rules, since we have 3 significant figures here, and we don't use 10 to the power for zig figs, we just use the number part. Since that has 3 zig figs, we get 3 zig figs. Now I'm going to show you how I put this into my calculator. I write 6.25, well, I need to turn it on, 6.25 second EE 2, 2, and I want to raise this to the 3rd power, so I can do caret 3, and I'll get the correct answer. And we can estimate the answer. I did this earlier today, but the answer in my mind should be around 2 times 10 to the 8. No, let me think about that. About 1.5 or 2 times 10 to the 8th. So let's push the equal sign here. And we get 2.4, and I'm going to change this to scientific notation. And we get 2.4 times 10 to the 8. So for A, we want to write 2.44, 3 significant figures, times 10 to the 8. Now let me show you another way to do this. You could do parentheses 6.25 times 10 to the 2nd power, parentheses, and then 10 to the 3rd power. Oops. Times 10 caret to the 3rd power. And we should get the same answer, 2.44 times 10 to the 8th. Oh, and I made a mistake. Let me try that one again. 6.25 times 10 caret 2. Oh, and I forgot my parentheses. Gosh darn it. So I probably have to start all over. So there's the 6.25 times 10 squared. And then I want to raise this to the 3rd power. So I got to do this, that 3, and that raises it to the 3rd power. So there's the 2.44 times 10 to the 8th. That takes more effort on, in my mind, than it does the other way. So either way, you need to be able to use your calculator correctly. Now the deal is since you have this answer here written in your notes, you can go back and practice this and see if you can get the same answer. Find a way that you're comfortable with so that on the test, you don't have to figure it out and burn time figuring out how to do something. Okay?
Okay.
Let me pause the recording here. Okay, for this next problem, we have 2.35 times 10 to the negative 3. So there's a number of ways to do this on your calculator. I've got this little square root thing right here. So I'm going to press that. And you can see I have square root, and then I put whatever I want in the square root. So I'm going to put 2.35 second EE negative 3. And I don't know if we need the last parentheses or not, but I do know that the answer should be bigger than 2.35 times 10 to the minus 3 because we're taking the square root of that. So that means whatever answer we get, if you square it, you should get 2.35 times 10 to the minus 3. So let's go ahead and put equal and see if we get, oh, and there we go, 4.8. Now, how many significant figures are we allowed here? And the answer is, since we have 3 there, we're allowed 3 there. So what do we write down? We write 4.85. And then times 10 to the minus 2. So in this case, how do I check my answer? And the answer is square that. because if I square that, I should get this answer here. So I'm going to square it, and here's square it, boom. And I get 2.35 times 10 to the minus 3. For C, I'm going to do 2.35 second EE minus 3. And then I'm going to raise it to the 1/3 power. Now, when I raise it to the 1/3 power, I want to use parentheses on the 1/3. Like that. And that should give us the correct answer. And we get 1.3 times 10 to the minus 1. 1.33. 3 significant figures because of the 2.35. Okay. So all of these problems so far have just been multiplication and division. This problem has subtraction in it, plus it has multiplication and division. So I want you to give this one a try. See if you can get the answer, and then also determine how many significant figures it can have using those rules that I gave you for how many zig figs you get. When you're done, just let me know. And I'm going to pause the recording because you don't want to watch someone just working. And when you're done, I will recording here. So the way I would do this is I would divide this side by 0.0821 times 273 so that these cancel. But the golden rule of algebra is what you do to one side of the equation, you do to the other side. Otherwise, it doesn't stay equal. Okay, so I'm going to show you how to put these numbers into a calculator, but first we're going to estimate the answer. So 0.08, I always use as 0.1. 0.1 is bigger than 0.08, I'll grant you that. But I don't like 0.0821, I like 0.1, it's 1/10. What's 1/10 of 273? It's 27. Now, here, I know it's not 27 because 0.08 is less than 0.1. So I'm going to say, you know what? It's not 27. It's a little less. It's a 23.4. Now, why did I choose 23.4? Well, because 2.34 over 23.4 is the same as 1/10. How many times does 10 go into 15.6? 1.56. So that's my ish. Ish means I think n is about that number. That's it. Now I'm going to zoom in on my calculator and I'm going to show you the quickest way to put these numbers into your calculator and get the correct answer. So what you're going to do is you're going to write 2.34 times 15.6. And then you can see I need to divide by 0.082. So divided by 0.0821. And then I'm going to put divided by 273. So I get 1.63. I want 3 significant figures. So 1.63 is my answer. So how does my ish compare to my answer? And the answer is really well. The reason I do an ish is because if I plug these numbers into my calculator and I accidentally get this as my answer, 16.28, I think to myself, wait a minute, I must have not used my calculator correctly. Okay, so a kind of a key to using your calculator, I'm going to zoom out now. Is if you have A times B over C times D, you can put it into your calculator like this. A times B divided by C divided by D, and it works every time. Another way, of course, to do this is to do A times B and maybe put parentheses around that, and C times D and put parentheses around that. So this is another way. It works well also, but there's more keystrokes involved. So I like this way better, but you just need to make sure that whatever method you use, you're comfortable with it. Now, going back to this problem, do you see how we have 3 significant figures here, 3 here, 3 here because leading zeros don't count, 3 here, so we end up with 3. Okay, so we're going to move on unless you have any questions. If you have questions, just feel free to speak up. Give this one a shot. Try and figure out what n is equal to, and I'm going to give you a little hint. This is actually a problem that we'll be doing in the future. This number here has 4 significant figures. This one has 4 significant figures. Both of these numbers are exact, so they have infinite numbers of significant figures, and the one here is infinite. So see if you can calculate the value for n with the correct number of significant figures. And I'm going to go ahead and pause the recording and show you what I would do. So I'm going to try to isolate n on one side and put everything else on the other. So to do that, I'm dividing the left side by 1,312, and I'm dividing the right side by 1,312. And naturally, 1,312 divided by 1,312 is 1. And I'm not going to write 1 times this, although I could. Now, I don't like this 1 over 2 squared. And since the 1 is exact and the 2 is exact, I'm going to go ahead and just make that 246.0. And here, I could actually play with this if I wanted to. What I mean by that is I could do the work. I'm going to leave it. So I've got negative 246.0 over 1312 is equal to, I'm going to put 1/4 1 over n squared. And then I'm going to subtract 1/4 from this side and subtract 1/4 from this side. So I get 1/4 minus 246.0 over 1312 is equal to negative 1 over n squared, because 1/4 minus 1/4 is 0. Now I'm going to take this and I'm going to multiply everything by negative 1. So I get 1/4 plus 246.0 over 1312 is equal to 1 over n squared. And then I'm going to take my work up here. I'm going to take 1 over n squared and divide it into 1. And that means I'm going to take all of this and divide it into 1. So I'm going to put brackets around that. And then I'm going to rewrite this. Whoops. And then I'm going to take the square root of both sides. So n is equal to the square root of 1 over 1/4 plus 246.0 over 1312. And let's make an estimate as to the value of n. We're going to do this in our heads. Approximately what is 246 over 1312? Well, I know that 246 will go into 1,000 4 times, so it'll go into this 5 times. So the bottom there is really 1/4 plus 1/5, which means the bottom is 0.25 plus 0.2, which means that the bottom is 0.45. So everything in parentheses here is about 0.45. How many times does 0.45 go into 1? 2 times. So what is the square root of 2? It's about 1.4. So that's my ish answer. So I'm going to write this down again. And we're going to figure it out with the correct number of significant figures, okay? So I'm going to change things a little bit. You see how I have n on the right here? I'm going to put n on the left and everything else on the right. So when I work it out here, I get 1 over 0.25 plus, and this 0.25, since the 1 is exact and the 4 is exact, you can't see what I'm writing very well. I apologize. So I'm going to move that down a little bit so that you can see it. So I've written everything again, but the n on the left and everything else on the right. And then 1/4 is 0.25, and this has infinity significant figures because the 1 is exact and so is the 4. And when I put these two numbers into my calculator, I've got 4 significant figures and 4 significant figures. So I get 0.1875. And this is good to right there. So now I'm going to add these two numbers together. And we get 0.4375. Since this is good to the 4th place over from the decimal, and this is good to infinity places over to the decimal, this is good to 4 places over from the decimal, which is right here. So now when we do this, my calculator gives me 2.2857. This one is exact, infinity zig figs. This has 4, so this is good to right here. And now I'm going to take the square root of that number. And when you take the square root, it's like a multiplication or a division problem. So since I have 4 significant figures here, I get 4 here. And I get 1.512 is my answer. And if you'll remember, our ish was 1.4 and this is 1.5. So I'm pretty sure I did the calculation correctly. So it turns out you end up with 4 significant figures. All right. That is a tough one. Is there more than one way to do this? And the answer is absolutely. You could have done this. So just a really quick thing here. Minus 246.0 is equal to 1312 over 4 minus 1312 over n squared. You could have done that and worked it out, and you would come to the same conclusion. Any questions about this one? Give me a, well, actually, let me ask you this. Are we okay to move ahead? So that would be a yes if we're ready. Okay, so I'm going to go ahead and move ahead here. The separation between carbon atoms and diamond is 0.154 nanometers. What is their separation in meters, in picometers, and in angstroms? So angstroms is something I don't teach in this class, but it is in your book. We'll look at that in just a moment. But let's do picometers first. So I want to convert that to meters. So one way to do it is to know that 1 nanometer is 1 nanometer. That's a given. But it's also a given that 1 nanometer is 1 times 10 to the minus 9 meters, because I can take that n and I can actually write 10 to the minus 9 there, because the n actually represents 10 to the minus 9. N is an abbreviation for 10 to the minus 9. You'll notice when I go from the above to the below, I only change one of the n's. So I'm going to use this equality as a conversion, which means I'm going to take one side, put it on the top, and one side, put it on the bottom. I decide that I'm going to put 1 nanometer on the bottom because I want my nanometers to cancel. That means I'm going to put this on the top, and we get 0.154 times 10 to the minus 9 meters. And this is a perfectly valid answer because it does not say what is the answer in scientific notation. It does not ask what is the answer in fixed notation. It just says what's the answer. And this is a good answer. Now, let me show you how I can put that into scientific notation with my calculator. So if I get 0.154 second EE negative 9, so there is that value. I'm not sure. Can you guys see that 0.154 EE negative 9? Okay, so I'm going to put equal, and you see I get 1.54 times 10 to the minus 10. And I can put it in decimal notation by doing second this and moving back to flow. Actually, it won't put it in decimal notation or fixed notation because there's not enough digits here to do it. So this is a perfectly valid answer. And if I ask for scientific notation, I can let the calculator do it for me. Another way to turn this into meters is to do this. That's a valid way to go from nanometers to meters. Substitute 10 to the minus 9 for meters, and we're done. Are there any questions about changing this into meters? Okay, let's change it into picometers. So for picometers, I'm going to take my nanometers, turn that into meters, and then turn that into picometers. And I know that 1 nanometer is 1 times 10 to the minus 9 meters. I know that 1 picometer is 1 times 10 to the minus 12 meters. So I'm going to have 0.154 nanometers times, and I'm going to put nanometer on the bottom again, and 1 times 10 to the minus 9 meters on top. And then for this second conversion, I'm going to put meters on the bottom. And you can see all of the units cancel except for picometers. And now it's a simple matter of just dealing with the exponents. And the way I deal with it is 10 to the minus 12, when I put it on top, becomes 10 to the positive 12. 10 to the positive 12 times 10 to the minus 9 is 10 to the positive 3. And so we get 0.154 times 10 to the 3 picometers. And this is a perfectly fine answer. Now, if I remember, Rebecca, you have kind of another way of doing this, and it would be something along the lines of this, where you would put nanometers on the bottom and picometers on the top, and you would put the correct numbers here.
Right, just the difference.
And do you know what it is?
Just 10 to the 3.
Okay, you're going to put that on top or the bottom?
The top.
Like that?
Yep.
And let's see what you get here. And can you see that you get the same answer?
Uh-huh.
Why did you put the 10 to the 3 on top?
Because it's the smaller unit.
Because a picometer is a smaller unit and the bigger number goes with the smaller unit. Okay? All righty. So that's how to do picometers. Angstroms, don't worry about it unless you're taking a physics class, and let them show you how to do it. Okay. Let's take a look at this next one. I'll let you take a moment to read this. This will be our last problem. Now, let me show you a way to do it that gets you the correct answer, but it doesn't show your work very well. So that's the correct answer, but you're not showing your work very well.
I mean, what would be wrong with that since it's 65% and 35%?
Because this is 1.53 grams of cisplatin, right?
Right.
And that equals 0.995 grams of platinum. How
Oh,
does it go from cisplatin to platinum?
I mean, you take away the cis.
You just do it because you think it's, well, because you know it's right.
I don't
Let
know.
me show you a better way to do it. So 65.0 mass percent means, by definition, 65.0 out of 100. The definition of percent means over 100, and the 100 is exact, it's defined. The other thing about percentage means that it's part over whole. So in this case, the 65% mass percent of the metal means 65.0 grams of platinum over 100 grams of cisplatin. That's what 65% means. Or it could mean 65.0 pounds of platinum over 100 pounds of cisplatin. The point here is that I can use any unit of mass and it's perfect. So if this is the ratio, do you see how I can take 1.53 grams of cisplatin, multiply by 65.0 grams of platinum and 100 grams of cisplatin, and we get the same answer as above. But can you see how the units change to grams of platinum? So this is what I expect. This, I'll give you half credit. Half.
So
But
we
this-
just have to really, even though we know that's how to do
Yeah.
it, we have to write
Yeah.
everything out.
It's not good enough for me, and I'll show you why. Let's say that you have 0.0052%. Change that into a decimal. What do you get?
0.52?
No, it's 0.000052.
Oh, it's the other way.
Yeah. So the only reason you get this one correct is because it's close to 1 and you know which way to move the decimal.
No, if I had more time, I feel like I would, and I wasn't on video being recorded, I feel like I would get that right.
Maybe so, but I would bet money that you get that right, not all the time. Now,
Okay.
if you use the definition of percentage, and this is one thing I don't like about math, they say, just remember which way to move the decimal. Screw that. Don't remember which way to move the decimal. Remember to divide by 100. Always divide by 100. Now, if you're dividing by 100, which way are we going to move the decimal? Here's the decimal.
Well,
If
it's
you're
getting
going to divide by
smaller.
100, which way are you going to move it?
To the left.
To the left. Suppose it's 0.0052 and you divide by 100. Which way are you going to move the decimal?
To the left.
To the left. In math, they should teach you that percentage is not move the decimal over to the left. They should teach you decimal means divide by 100. And because you're dividing by 100, move the decimal to the left. So the move the decimal to the left is a trick. I'm not that fond of tricks. I'm fond of understanding. And you have to agree that when you look at the problem up above versus the problem down below, which one is a person going to look at and understand exactly why it's grams of platinum at the end? Whereas when you look at these two problems, are you going to believe the top one or the bottom one? Which one is more believable? And it's clearly the bottom one. So something you have to get used to. Whenever you see a percentage, immediately put it over 100. So
But you do give partial credit. You just mentioned that you'd give
Yeah.
half credit.
I'll give you half, Rebecca. Half.
Well, I'm not gonna try to do that on an exam, but it's gonna be hard to remember all of the little things like that that you want.
Oh, it's easy. So instead of writing 100%, what do you write? 100 over 100, 100 over 100. Instead of 92%, what do you write? 92 over 100. And just remember, the top part is the smaller part. The bottom part is the whole.
Okay.
So iron ore, if you've got some really good iron ore, it's 36% iron. So that would be 36 grams of iron over 100 grams of ore. And that's far better than moving the decimal over. Let me show you another reason why you don't want to move the decimal over. Do you see how we move the decimal over here, Rebecca?
Mm-hmm.
How many zig figs should we have in our answer?
Just 2 since.
Right, so it'd be
Leading
1.0. But do you see how 65.0 has 3 significant figures?
Right.
And when I do this down here, do you see how it still looks like it has 3?
Uh-huh. I do.
So-
So that I would get the wrong answer with the significant figures for sure if I did it the other way.
Right, and you don't have any justification for why 1.53 grams is equal to 1 gram. I mean, because that's what you're basically saying here.
Even if we like wrote it out, like if I forget about that, if I wrote it out.
Well,
which-
here's how you're going to practice.
calculations
Here's
for-
how you're going to practice this one, Rebecca. You see this problem here?
Uh-huh.
I've just shown you the solution, right? Throw it away. Now that I've shown you the solution, see if you can do it without me telling you how to do it. And this is something that you'll get used to after you do it about 2 or 3 times.
Okay.
Okay?
I think I'll remember.
Go ahead and write it out. Trust me on this. Write it out and you'll feel a whole lot better. I promise you. Okay? And if I'm wrong, you can tell me tomorrow. Sound good?
Yep.
All righty. All right, so we turn our mics back on at the end of the session and we say goodbye to everybody.
Bye, guys.
Bye.
Goodbye. I'll be posting this hopefully in an hour or 2.
Okay.
All right, bye-bye.